Hello, good morning, good afternoon, good evening, wherever you are in the world. This is Nick Hodges, the Director of Engineering at Embarcadero, and I'm here today to talk to you about dependency injection in Delphi. My contact information is there for your use if you want to talk to me. And let's get started. So the code for this talk can be found at the following bit.ly link, DI in Delphi. So if you want to download the code, or any of the code, some of the code that I've shown, particularly the file viewer application that we'll look at the end of the presentation, you can do that. So what is dependency injection? Well, dependency injection is really a 25 euro term for a 10-cent concept. It's something that's very, very powerful, but very, very simple. Dependency injection is really just the notion of asking for your dependencies. Don't create them. Simply ask for them from another entity that creates them for you. Imagine you had a house that you were looking at buying and it didn't have any plugs in it. Everything was hardwired into it. All the appliances, all the lights, everything was hardwired into the wall with no plugs. This would be a house without dependency injection because it would be a house that had no interfaces for the electricity throughout the house. And without that electrical plug to plug in items, you lose a lot of functionality and a lot of capability and a lot of flexibility to change things from one to another. You need to unplug your vacuum cleaner to move it from room to room. You wouldn't want it You wouldn't want it hardwired into a wall socket in the basement. So a house with no plugs is like a house without dependency injection. So what is dependency injection? Mark Seaman in his book dependencyinjection.net says it's a set of software design principles and patterns that enable us to develop loosely coupled code. And that is really all it's about, is developing loosely coupled code. Now, loosely coupled code is good. So dependency injection is just a means of creating loosely coupled code. It is not merely the use of a dependency injection container, as many people think. You can do dependency injection without ever touching a dependency injection container. And in fact, we will do a lot of dependency injection in our code demos before we ever touch the container. So since it creates loosely coupled code, your question might be, why would you want that? Well, because loosely coupled code is all kinds of goodness. If this is your class diagram, then you have heavily coupled code. So coupled code is really bad in that it's hard to maintain, it's hard to update, it's hard to change. You make a change in one area and it affects the performance or the functionality in a completely different area. Uncoupled or loosely coupled code, you can't have completely uncoupled code, you want loosely coupled code, is good because it allows you to easily and quickly isolate errors, to switch in implementations if need be. Any number of good things come out of having loosely coupled code. So if you're going to do dependency injection and you want to avoid dependencies, you have to wonder, what is a dependency? Well, a dependency is anything that a class needs to do its job. So for instance, T class A is said to be dependent on T class B when you can't compile T class A without T class B. In other words, if you just created a simple console application, put that unit in there for T class A, and it also pulled in and compiled T class B because of compiling T class A, then they're dependent on each other. And dependents are created when you actually, create one. You call create on an object in Delphi in your application. You create a dependency. And once you call create, you are stuck with that object that you've created. You can't change it easily to use a different implementation. You can't easily update that code. You can't easily maintain that code. Code that has dependencies is difficult to maintain. So here's an example of creating a dependency. Here we've got a widget class with a method called sendWidget. And internal to it, it creates a widget sender class, calls the method on the widget sender class, and then frees the widget sender. Now this is fairly normal code, and you're probably thinking, hey, I write code like this all the time. Well, What you've done here is you've created a dependency on the TWidgetSender class. If you write a better implementation of TWidgetSender, or you need a different implementation of TWidgetSender, you are stuck with this particular TWidgetSender. You're going to have to create a new one, plug it in, write code, and you're connected to it as well. We don't know what happens when we call send widget. We don't care, but sometimes it may be connected to other things throughout the code that you don't want to be connected to. So creating TWidgetSender creates a dependency, and dependency injection is all about removing dependencies. So what are some basic rules to follow for dependency injection? Well, first rule is code against interfaces or abstractions. Program to an interface, not an implementation. This was first made famous by the Gang of Four book, the Design Patterns book, written by the Gang of Four. Eric Gamma in particular is the one attributed to whom this quote is attributed. And this is probably one of the single most important things I would try and teach a new software developer, is to program to an interface, not an implementation. Now, rule number 2 is keep your constructor logic very simple. If your constructor is doing more than straight assignments, you're probably not doing it right. You're probably creating and putting logic into your constructor for a reason that is not good. So here we have a OrderProcessor calling the constructor, and we're passing in two parameters, aOrderValidator and aOrderEntry, and we're assigning them to the internal fields that hold those values. And that's all the constructor does. If your constructor has an if statement in it, you probably need to split that constructor into two halves, two new classes. If your constructor has any kind of logic in it, then you need to find a new place for that logic. Constructor logic should be very simple, should be simple assignments. Rule number 3 is don't actually create anything. Don't actually construct anything. Delegate the task of creation to objects whose specific job it is to do that, whether it be a factory or a dependency injection container. You should, as a general rule, avoid constructing anything. Now, we'll talk a little bit later about what some of the types of classes that you will want to construct. But as a general rule, if you wrote the class yourself, don't construct it. Use some type of object creator, some type of factory, or a dependency injection container to create it for you. In other words, I want you to use constructor injection as much as possible. I want you to inject a class's dependencies into that class through the constructor. So there are 3 types of injection. I talked about constructor injection a moment ago. We'll talk about it here a little more thoroughly. Here's a perfect example of constructor injection. You've got a class called a tFruitGrove. It's got a constructor that takes a tFruit or an iFruitPicker interface. It stores that interface locally in the fFruitPicker field. And then when comes time to pick the fruit, the fruitpicker.pickFruit method is called. And this is a beautiful example of constructor injection. The constructor declares to the world, hey, I need an iFruitPicker. It doesn't say how the iFruitPicker should be implemented. It just says it needs an iFruitPicker. And that is something that you must pass to the class in order for the class to do it. You don't want to create the tFruitPicker inside the constructor, because then you'll be stuck with that one particular fruit picker. Here we're programming to an interface against an iFruitPicker, and we're passing it into the constructor as a required field for the class to do its work properly. You should use constructor injection to, as I said, declare a class's required dependencies. This should be the primary way of doing dependency injection. A class has a set of requirements, has a set of dependencies, hopefully only 1 or 2, maybe 3, but if it gets past that, then you should think about breaking that class into more subclasses, or I'm sorry, smaller classes, not subclasses. And those dependencies that you inject through the constructor should be the required dependencies for the class. Next kind of injection we'll look at is property injection. Here we have a iNinjaStar interface that has a procedure on it, throw, and we don't necessarily want to create a ninja with a throwing star, because every ninja has a sword that's required, as we can see by the constructor, but the ninja star is injected as a property and set as a property in order to allow you to vary what kind of ninja star you throw, but allow you to provide any type of implementation for that ninja star, and you can inject that dependency, the ninja star dependency, via the property value by setting a property after construction. That's property injection. You should use property injection to declare optional dependencies for a class. That is, dependencies that a class doesn't necessarily need but might want. And it's normal for you to provide a default implementation of that optional dependency. It can be a totally functionless dependency, so there's no nil values in your code, and you can simply create that dependency as a functionless object in your class. Here's method injection at work. Again, we've got a ninja star and a ninja sword. We have a ninja who takes a sword as the required dependency through the constructor, but there's a procedure called throw ninja star that takes a single ninja star as a implementation, an interface, an iNinja star interface as a parameter in the method throw ninja star. And presumably you would do some kind of code that actually would call the throw method on the ninja star interface. Use method injection when the dependency will vary frequently or when the dependency needs to be disposed of after each use. So in the case of our ninja star, there may be any number of ninja star types, 4-pointed, 5-pointed, 20-pointed, whatever types of ninja stars that you want to throw, and you don't want to have to manage all of those as dependencies in the constructor when you want to just throw a star right away. So you can use method injection to pass in any type of star, ninja star that you want. So that is a varying dependency. You use method injection. Now I said earlier don't create anything, but that's not entirely true. I didn't lie to you, but I encourage you to not create things unless they are what we call or might refer to as a creatable. A creatable is a class that you should be creating manually. That is something like tStringList, or RTL or utility classes inside of the libraries that you use that are non-volatile. They don't change. They are firmly fixed in your code. They don't vary, and they don't need to be used or should be used inside of a container or passed around as dependencies. Now, an injectable class is a class that you should be asking for through dependency injection. There are classes that you've written as part of a business logic. They're usually volatile. They're changing. They're altered. Their properties change at runtime, things like that. Basically, classes that you write yourself should be injected. Classes that are part of a library should not be injected. They're creatables. You should be able to create them, and injectables are things that you should inject. So what are the benefits of dependency injection? I'll run through this quickly. First, maintainability. Application that uses dependency injection and proper dependency injection is highly maintainable, mainly because each individual class is separate from each other, doesn't cause errors. Making a change in one class doesn't cause changes to other classes in the application. Highly maintainable is a benefit. Classes are very testable when they're loosely coupled. If they depend on dependencies that are handed to them, you can hand them mock dependencies instead of regular dependencies and test the classes in isolation, as you should be doing with unit testing. Dependency injection makes for a very readable code. Classes are simple and small. They generally will follow the single responsibility principle if you're coding well. And so your code is easy to read, and each individual class is a simple, straightforward thing. Classes are also very flexible. Dependency injection allows them to be used in multiple ways and reused in ways that you might not conceive of at the time that you write them. So a dependency injection lets your classes and your application be very flexible. You can easily replace a given implementation with another implementation, and you can do that on the fly. You can do that at design time whenever you want. Dependency injection based applications are also extensible, because it's easy to inject required functionality, it's very easy to inject something new or to inject a new implementation that enable you to extend the capabilities of your class and your application. Dependency injection also allows for parallel development. What do I mean by that? What I mean is that two groups can be working on a project before either group is done with the project, because what you can do is you can just declare an interface and then code to that interface and give the other team that interface for your service, and they can code against that service knowing that sometime in the future your service will be implemented. So it allows for teams to work together much more efficiently, because once you define an interface, you can code against that interface without actually having an implementation of it. So you can code against the interface before the interface is actually implemented. So let's talk a little bit about the dependency injection container, finally. I've mentioned it a number of times. Eventually, if you keep pushing back the creation of your objects, that is, you continually push objects to be created at the composition root of your application, your composition root will get really busy. What I mean by this is as follows. Let's say you have a class that has a dependency, class A has a dependency on class B, so you pass an interface of type I class B to class A. Well, at some point that object has to be created. So if you're continually passing back the information, the creation of objects, and you're continually pushing them back, pushing it back, you'll eventually get to the composition root, which in Delphi applications can be either the DPR file or sometimes the main form create file, main form creation, either the onCreate event or the constructor of the form, your main form. And so that's the place where all the creation and the connections between the classes and the dependency injection dependency constructor injection takes place. So at that point, there should be a whole bunch of things to be created, and we'll see this in the demo. So we need a solution for creating all these objects painlessly and without a mess, and that is the dependency injection container. A dependency injection container is a container that takes on the task of creating objects for you. It can do it automatically on the fly when a dependency is recognized by the container as being needed by another class that's been registered with the container. So the dependency injection is a very powerful factory for creating tasks and objects for you. It should create every object that you need that are injectables. It shouldn't create creatables, but any object which is deemed injectable should be created by the dependency injection container. And luckily, Delphi has a very powerful, very capable dependency injection container as part of the Spring4D framework. You can find it at spring4d.org. It's maintained by Stefan Glinke, who has done a great job maintaining it. The Delphi container, the Spring4Delphi container can create objects, it can implement interfaces, and it can manage the object lifetimes, the lifetimes of those objects that you do create. So it's very powerful. So a container can manage injection for you. It can automatically do constructor injection and property injection. You can use attributes to declare that something should be injected. You can allow for custom constructors to be called via the delegate to call. And you can manage the lifetimes of the objects by calling as singleton or as per thread, things like that, enabling you to manage the lifetime of the objects. Lifetime management is done at creation point. The default is transient, meaning that it's created and you are responsible for freeing it. You can also call a singleton per thread. You can pool your objects if you want to, if you have a pool of objects. You can do any number of things. You can even implement your own lifetime manager by implementing the iLifetime Manager class interface with a class. Okay, enough slides. Let's go take a look at some code. Okay, for code, we're going to take a look at two applications. One is a very simple application that demonstrates very simply how you can take an application that is highly coupled and decouple it. And then the second one will be more of a real-world example of file viewer from my book Dependency Injection in Delphi. So this first application here is called Starting Out, and that's because we're starting out with Dependency Injection. And it just does something very simple. It processes an order. So if we go look at the OrderProcessor, you notice it creates an order processor, calls process order, passing in the order, and then writes order successfully processed. Frees everything up, no big deal. The order processor is the place where the real money hits the road. Rubber hits the road. Money doesn't hit the road. Rubber hits the road. And it's the place where we actually create an order validator and an order entry system. The order is valid by the order validator. Then we go ahead and enter it into the database, and the order, say the order has been processed. An order is just a simple class that does nothing. An order validator is just a class that returns true if the order is not nil. And an order entry is again just something that returns true if the order is not nil and writes out to the console. No big deal. But again, the real money is made in this order processor call here, this process order class. Now, this application is very highly coupled to these two classes, order validator and order entry. If I wanted to, for instance, test this class, OrderProcessor, I couldn't really use unit tests because I would have to call the real order validator and the real order entry classes. And trying to get a mock class into this class would be very difficult because it doesn't use constructor injection. Well, let's fix that. So I'll take a order validator of type T, order validator, as well as an A order entry of type T, order entry, like so, and I'm highly meticulous, so I will do that. Then we grab this to copy it up to here, and instead of creating these classes, now we've passed them in. A order validator, and the order entry gets A order entry, like so. Now this all works fine with one exception, of course. Now that when I construct this thing, I've got to pass in an order validator and an order entry. So we'll simply go OV T order validator and OE T order entry, like so. We will create them as needed here, or create the order entry now. Order entry gets T order. Oops, got to line up. Can't have your code out of whack. T order entry dot create, like so. And now, once we create them, of course, we need to free them, and we'll ov.free and oe.free, like so, and this should work. And it does. Okay, so now we've moved the creation back one level. Let's move it back even further. Let's do this. Let's take a order. Well, let's be a little more efficient about it. Let's go to the order processor. Let's take this, copy it, go deorder processor, take it there. Let's grab these things here, and we'll actually take them back to the very beginning here and put them here like this, and we're just pushing this creation all the way back to the root of the application, the composite root of the application. And OE, like so. And then of course now we have to go to do order processing and make sure that this is also part of the declaration, so that we can then, if we try and run this, we'll just move this whole uses statement up here like so, and that should all line up. Then we'll go back to here and we'll pass in, we need to pass in order validator and order entry like so, and save everything. This should work, and we run it and we get an error because we should go try OE.free, OV.free, and we need to go back over here and take that out. Actually, take this try out like so, and now it should run. And it does. Boom. Okay, so now you'll notice that we've got the constructor of this all the way back to the very beginning of this application. It's right in the composite root. It's in the DPR file. We can't push the construction back any farther. But we're not doing something that I said we should be doing, and that is coding against interfaces. So I'm going to create a unit. I'm going to add a unit that is already existing called EU interfaces, and I'm going to have these classes implement these interfaces. So order validator, for instance, should just simply interfaced object implement iOrder validator like so, and then order entry, it should t interfaced object comma iOrder entry like so. So now those classes need to know nothing more, or interfaces, excuse me, and we can come back here to the do order processor play location, and we can get rid of these declarations. We don't need them anymore. We can change this so that it takes this as an entry and this. Actually, I should have done this earlier, shouldn't I? Yes, I should have. Like so. Whoops. Now I got order validator, a order entry. To make sure this compiles. And it all compiles, that's good. See if it runs. Runs, and that's good. But now we want to code against these interfaces. So basically what I want to do is I want to change this interface, change all these to interfaces. Interface, change this to an interface. And now you'll notice something really cool. You'll notice that because I can use the U interfaces unit here to get rid of the squigglies there, I don't need to use these two units anymore. I don't actually have to couple myself even to the units that declare what an order validator and an order entry class implementation is. Excuse me. So it doesn't matter. I can just take it and go against the interfaces, and now you'll notice that this unit doesn't even depend on those other classes in the implementations units. So now I'll let the compiler tell me where my errors are, and the compiler is going to tell me that A order validator and A order entry are not the right thing that this constructor is expecting. So again, we'll make the constructor expect in interfaces like so. We'll remove, again, decouple the two units by removing their declarations like so. This becomes an I order validator. This becomes an I order entry. Same with this down here. So now we're coding against interfaces. Let the compiler find any errors that exist. And we can run it. And we get an error because we're not passing interfaces here. We don't need the try finally anymore because we're passing interfaces like so. And everything's an interface now, and everything should be decoupled. And we run it. And it works. So now we've got ourselves in a situation where let's go back to the good old order processor, and you'll notice that this order processor doesn't know anything about anything except interfaces. It doesn't know anything about how to process order validators. It doesn't know anything about anything except interfaces. Notice the unit just uses the orders unit, which we won't worry about the orders class, and the interfaces unit. And that's it. That's all it uses. Same with order validator. Order validator just uses the unit interfaces. Order entry just uses the user interfaces entry. That's it. So if we go back to the root of the application, you'll notice that these constructors here are at the root of the application. Now, this is a very simple application. You can imagine a complex application that was done the same way. There would be tons and tons of calls to create here that need to get passed into procedures that get sent out to do multiple things. Excuse me. So this creation stack here could kind of get not so pretty. Well, let's use a dependency injection container to take care of the creation of these objects for us. So we will add a unit that I've got prepared already. So we have this unit. It's called register stuff, and you're not going to believe this, but what it does is it registers stuff. Okay, so we've got a register stuff. We pass it a container of type T container, and T container is the type in the Spring.container unit that is the container or the dependency injection container that we're going to use. And let's see, I've also added a little code here to create the container. So we'll create it. We'll call try, and of course we have to container free when we're done. But that's one constructor that's good to do because we're right there in the root of the program, so we can create things if we want to. Now, let's hold off on talking about this registry just a second and do a couple more things to make our application even more dependency injection oriented. Let's go to OrderProcessor, and let's make OrderProcessor an interfaced object. And it's going to implement OrderProcessor like so. And if I go to OrderProcessor, the order is const, so it's not going to compile if I don't change this to const here and const here. Let's make sure that compiles. The compiler is your best friend when trying to figure out whether your code is in syntax is correct. Well, it won't tell you your code's correct. It'll tell you your syntax is correct. But you get the idea. Let the compiler find your errors when you're doing this kind of thing, this kind of refactoring. So now the OrderProcessor gets created in the doOrderProcessing event, and we want to create an OrderProcessor instead of a OrderProcessor. And now we don't have to free it like so because it's an interface, and we refactor it like so. Now the OrderProcessor is being used instead of the TOrderProcessor. Okay, so the next thing we're going to do is this doOrderProcessing call, in fact, doesn't need these two parameters. All it's going to need is a single order processor, which is of type IOrderProcessor, right? And now we don't even need this reference here because we are going to use, we're going to take this line, I'm going to take it, copy it actually. I'm going to exit out. And we're going to use OrderProcessor as the processing of orders. So now we'll go back. We're continually pushing in the process of pushing our construction back to where we want to go. So we want to register stuff. The doOrderProcessor doesn't take an order validator or an order entry anymore. It simply takes an order processor. So we don't need these two anymore. Like so. And we go OP equals container dot resolve I order processor like so. Okay, we run it and we realize that we forgot to change the implementation declaration like so. And we run it and we don't need this order processor anymore, and we run it and it all runs. Now, should have noticed something very, very curious going on. At no time throughout the process, well, first let's look at the register stuff as I promised. Here we have a container, and I take the container and I'm going to say, look, I'm going to register a type with the container. The type I'm registering is TOrderProcessor, and that TOrderProcessor implements IOrderProcessor. Same with IOrderEntry, TOrderEntry, and IOrderValidator, and TOrderValidator. And what this does is it tells the container that when I have an IOrderProcessor appear, create up a new new order processor for me and pass it in return. So you'll notice that that's what happens here, what we call resolve IOrderProcessor. So I resolve the IOrderProcessor to return me an instance of an implementation of OP or IOrderProcessor, right? And it passes that order processor into the IOrderProcessor doProcessor order class there as it has, or function, excuse me, as it's always done. But you'll notice that the TOrderProcessor class doesn't actually create, or in no place in the entire application, in your code anyway, are these order validator and order entry classes created. And that's because they're automagically created by the container when needed. The container, I register the TOrderProcessor class with the container. The container looks at that TOrderProcessor class and it says, hey, this constructor needs an IOrderValidator. I know about IOrderValidator. I know how to create one. And it needs an IOrderEntry. I know about IOrderEntry. I know how to create one. And it does it automatically for you inside the container. So you never have to worry about even creating your own stuff at all. All you do is have the container create it for you automatically. And that's the beauty of dependency injection, is that now we have an application where the order unit's all by itself. The order validator is completely decoupled. This is a very testable class, right? You can pass in fake orders. The only thing it knows about is the iOrder validator interface. The order entry is the same way. And then OrderProcessor, which, if you recall, was the class at the very beginning that was very highly coupled, is now coupled to nothing more than a bunch of interfaces. The container does all the work of creating everything you need. You can make a single call to the container resolve, like so. You call do order processing, passing in the order processor, which has been properly created and has been properly instantiated with the order validator and order entry that it needs, because the container knows how to do that. And the code will work as expected. But you'll notice again that this code is all now is very, very loosely coupled. Really, the only coupling takes place inside this unit with these uses clauses here, which connect up the interfaces with the classes that implement them. And that is a well-contained little unit where the coupling takes place. Otherwise, all your classes are standalone classes that know how to do one thing and one thing only, and they magically create all the code, all the classes that you need when you need them via the container. Okay, so we're running a little short on time, so I'm going to quickly take a look at the file displayer application that, again, is part of my dependency injection in Delphi book, which you can purchase at leanpub.com. So this application is pretty straightforward. It does one thing and one thing only, and that is display files. It'll display any file. Bitmap. This is a list of files that it knows how to display. So for instance, if I grab my title cover of my book, it knows how to display the picture that's the cover of my book. If I grab a PNG file, it knows how to show a PNG file. If I grab just a random file that it doesn't know about, it prints information that it can grab about that file. Like so, it can print text files, XML files, any kind of file that you want. It'll display basic information about it. Now, this application is completely modular and completely decoupled. So let's close all the other pages here and take a look at this application. First, let's look at the main form. It just consists of a panel, a couple of buttons, and a list box. If we go to the code, you will see that there's not a lot of code here in the form. Matter of fact, there's almost none. The first thing is, though, it does create a container. It registers the interfaces to the container, and it registers a bunch of displayers. The displayers are classes that know how to display specific types of files. And you can create and add your own displayers if you want to, because it's totally modularized. And I suddenly realized that I create the container. Oh, no, I do free it. I'm sorry. I free it in the destructor of the form destroy event. I just simply put all the extensions into the list box so that you know what kind of files you can look up. And here's where the real money hits the road again. Register interfaces, takes a container, registers a T file displayer as implementing the iDisplay on panel interface. Same goes true for file extension getter and file name getter. Now here's where we have a bunch of displayers, a text file displayer and a picture displayer, that know how to register and display these specific kinds of GIFs and PNGs and bitmaps and JPEGs and whatnot, like so. So that's where all the registration occurs. The money is made again with this single resolve call here, which sets up the file displayer. And now the file displayer is ready to do its business. And the only thing you ever have to do is display on panel. It's called display on panel, and pass it the panel that you're displaying whatever file it is that the file displayer wants to display. So if you click on the button, only thing that happens is you call file displayer display on panel, and you pass it a panel. That's it. That's all that happens in the main form. And again, that's a very simple decoupled solution because all the rest of the work is done in all these other classes that are completely decoupled from the main form and from each other. So for instance, here's the notion of a file displayer. It implements the iDisplay on panel interface, and you create an addition. You pass in an iFile name getter and an A file extension getter, and it goes off and it gets a file name by calling the file extension getter get extension and the file name getter get file name. Once it does that, it calls the displayer and gets a display and just displays it by its extension, and then displays the file name in a given panel. This class is completely standalone. It only depends on a unit called FFileDisplayer Interfaces, which is probably pretty familiar. It looks the same as the one from the last example. This is a simple display registry, which we use to just hold on to the list of extensions and displayers, which will display that extension by the iDisplay file interface, by the way. It's just a glorified dictionary that manages that. The frame extension getter simply gets the extension from a given file name. The file name getter prompts for file name, and prompt for file name is a call inside of VCL dialog, so it just prompts you for a file name. That's all it does, and it sends the results back in the function, fills the result with the value that you pick, and that's it. It just returns that value. Picture displayers, again, here is a picture displayer. There's a text file displayer that creates a memo and aligns it to the parent and puts it on there. And you'll notice that all of these classes really depend on nothing other than this interface unit. And so the classes are completely decoupled. They're completely separate from each other. They're all testable. They're all easily manageable. And it's hard to make a change in one that will affect any other class because you simply are just connected via the interfaces. Remember, it's the registration, this registration function, where all the coupling takes place. And this is a safe, closed loop, if you will, of coupling that makes sure that everything gets registered and automatically created. You'll notice that I don't create, for instance, the file getter and extensions because the tFileDisplayer class knows about that. Oops. Now I've done it. There we go. And so we have a working, functioning application that you can take a look at in the source code that comes with this talk and my book. My book explains all of this, probably better than I did in this presentation, I hope. And I hope the book's better anyway, I should say. And we have an application that is a functioning, real application. It can easily be extended by creating new implementations of iDisplay file. Then you could register extensions against those new iDisplay files. No big deal. Very easy to manage, very easy to do. So let's jump back to the slides. So here's some other resources. I've mentioned my book a couple of times. It's called Dependency Injection in Delphi. You can get it at LeanPub right now, and the soft copies will be available soon on Amazon and CreateSpace. And another good book is Mark Siemens' Dependency Injection in .NET. It is very thorough and deep in discussion of dependency injection as well, but it is all .NET. I recommend my book, of course, but Mark's book is very good as well. So thank you, and now it is time for questions.
Great, thank you, Nick. So Steven's asking if there's a good introduction to using interfaces.
Coding in Delphi by Nick Hodges has a pretty good introduction into them. There's awesome. a lot of information on the internet as well as about using them. Probably a good source would be to study Dr. Bob's work on it with the solid. If you type in interface segregation principle, that'll tell you about a lot about how to use interfaces properly. If you search on Google for interface segregation principle, ISP, that's part of the solid coding, SOLID coding principles.
Uncle Bob or Dr. Bob?
Uncle Bob. Sorry, Dr. Bob. Yeah, Uncle Bob's more well known for that.
Dr. Bob may have stuff on it too, but
He may, but yeah.
Yeah, Uncle Bob's got some good stuff on Solid out there. Really good. And your book, Coding in Delphi, put a link in for that. That's a good place as well.
Thank you.
Take a look at the replay. Yes, great, Mark. Sorry you joined late. I guess you missed the audio problems, though, so that's pro. Maybe I have a question. You register all creation of objects in the container. What if the constructor requires more than other objects, maybe pass in integer values or enumerators or something else?
Ingo, that's an excellent question. I didn't get time really to cover that in the demonstration that I gave. There is a way to do that with, it's called register. You can register a factory class that matches the signature of your constructor, and then that teaches the container how to create something with a specific factory signature. And of course you can read about it in the book. There's a demo of doing that.
Yeah, I don't have the third one yet. I need to get the third one, but I have the other two very good books. I hear lots of good feedback from others. I tend to get, I will admit, very fanboy. So I always look to see if other people also agree with my opinions before I repeat them, because I just get excited. But I've heard really good feedback from other people on your books as well. So.
Well, I appreciate that very much. Thank you.
Sure. I got a Raspberry Pi 3 and I was just playing with it, so I'm a little distracted.
Oh, those are fun.
Yeah, I got Android in running on it and a Delphi app connected and running, and
yeah, I saw that on Facebook.
Just all worked really nicely. Okay, let's start getting to the questions.
Any other questions? I did a great job explaining everything, so there's no questions.
As usual.
Yeah.
So what's the difference between coding in Delphi and more coding in Delphi, if someone was curious where to start? Should they start with the regular first one and then go to the more coding in Delphi, or?
Well, that's what I'd recommend. Yeah, read the first one, read the second one. The second one is just more of the same kind of thing that you got in coding in Delphi. The second one covers, oh gosh, now you make me, hang on, let me grab one.
Actually, I was just looking at it here. It says patterns, threading, parallel programming, aspect-oriented programming, which is a really cool topic I'm a big fan of, and solid code is in more coding in Delphi.
Yep, so that's what you get, I guess. Thank you.
And the first one here, there it is, generics interfaces, which Stefan was asking about, exception handling, anonymous methods, collections, RTTI, runtime type information, enumerators, attributes, dependency injection, which you just talked about today, and unit testing. But your new one, dependency injection in Delphi, goes into way more detail, I take it, than the...
It does, and I've learned quite a bit about... I shouldn't say, well, I have learned, but there's been a lot of advances in dependency injection since I wrote the book originally. So a lot of different viewpoints, a lot of different ways of looking at things that are better and more better, more faster, more cheaper.
And now in the first one as well, you talk about unit testing. Do you get into mock objects in coding in Delphi as well?
I believe there's a chapter in there on mock objects. This has been so long since I looked at this thing. Yes, testing with an isolation framework. Isolation framework is the proper term for what is commonly referred to as a mock framework, but there is more to it than just mocks, as you will just learn when you read the chapter 14 in coding in Delphi.
Now, does your new book go into isolation frameworks at all, or is it purely about dependency injection?
It's purely about dependency injection. It doesn't talk about unit testing or mocks or stubs or anything like that.
Yeah, because that's one of the, from my understanding at least, one of the big advantages of properly loosely coupled code and dependency injection is that
it makes it very easy to test, yes.
And that's
Sorry, I interrupted you.
That's what I was going to say. That was my problem I had with unit testing a long time ago, is I was like, everything's so coupled, I can't test anything. And now it's like, oh, that's because I was doing it wrong. So.
Yep. If it's hard to test, you're doing it wrong.
Yeah. Does the book also cover abstract classes? I saw Delphi supports those as well, right?
I discussed that very briefly about abstract classes. I used interfaces throughout the book. You can use abstract classes as an abstraction. I certainly stress coding against an abstraction. If that's an abstract class, that will work just as well as an interface.
Yeah, abstract classes and inheritance are one way of doing things. I think interfaces is more flexible, more elegant, in my opinion. It took me a while to get to that opinion too.
It depends on your taste. Yeah, some people, don't really like, what do you call it? They don't like abstract classes. Some people don't like interfaces. Some people prefer abstract classes. Both will work just as well. And abstract classes actually have some advantages. One is that you can add functionality to that base abstract class that descends down through the other classes, and then that is an advantage that you can't get with interfaces. But the book covers abstract classes very briefly and deals with interfaces throughout.
Yeah, so let's see, where's this at? So there's a question here about MVVM.
Yeah.
And we just did this phenomenal session on advanced coding practices. I'm trying to find the replay for it here with Daniele Tete, and he came up with this framework called it Columbus Egg, which he showed this to me, and it's just like, wow, this is amazing. And essentially what you do is you have all your code, your data access objects in a data module, and then you use the Columbus Egg framework, and it creates an MVVM. So it completely decouples your form from your data access layer.
I gotta find it.
All of it for
you. Is this called the Columbus Egg?
Yeah, Columbus Egg by Daniel Tete.
Oh, I'm going to have to look at that. That sounds cool.
But he showed this to me. I'm like, oh my goodness, this is exactly it. Because everything I've seen before about
I'm Googling that as we speak.
MVVM has always been like, well, you write all the code from scratch. I'm like, well, that's what I like about Delphi is I don't have to write all this plumbing code from scratch, and this just makes it all work beautifully. I can't find it. Why can't I not find it? He did a webinar with us on, here we go.
Here it is.
So
I see it. It's on GitHub.
Yep.
Well,
so Daniele, yeah, he did he's got a couple books out as well, and a training based on those books and all sorts of great stuff.
Wow, that's great. I'm glad to hear that. That's delightful. We'll have to look at that closer today.
Trying to see if he should have a blog post that has the recent post. He's apparently a very prolific blogger because it's falling off the front page. But yeah, this is really good stuff here, if I can find it. Nope, I'm not finding it. Okay, but you found it was on GitHub. So
yeah, I just searched for Columbus Egg Delphi, and it came up.
Yeah, on GitHub. But he did a webinar with us on modern Delphi architectures.
And so actually it's at github.com/Daniel Tete, Daniele Tete /Columbus Egg 4 Delphi. So it's right there.
Yeah. So yeah, check that out. If you're wanting to do MVVM, awesome stuff there. Or I'm not sure if it's MVM or MVVM or MVC or whatever, but it's that idea of decoupling your data access layer from your
That's a terrific idea. Oh, I see somebody put it in the questions there, yeah.
Yeah, and it does it. The thing I love about it is it lets you do it all without having to write all that plumbing code yourself, which is brilliant.
One doesn't like to write plumbing code if one doesn't have to.
Exactly. I've learned that even though Delphi spoils me and I don't have to write code, I've learned it's okay to write code when I need to, but if I don't have to, I'm happy about that.
Yeah, that's use a library. Yep.
Yep. So very cool stuff. Fantastic, Nick. Thank you for your time and for all that you do.
You're very welcome. Very welcome.
Thanks to everybody for joining us for this. And
thanks everybody. Appreciate it. Appreciate you sticking around.
Yeah. And we'll see you all online later. Bye.
All right. Bye-bye.